And when this transistor will be stable, we know that this circle is telling about the unstable region. So what we are seeing here, this is the unstable region in the Smith chart. This is the unstable region in the Smith chart. This region we can't see because it is out of the Smith chart. Only this region alone we can see in the Smith chart. So this region is nothing but unstable region. And when the unstable region will be out of the Smith chart, because so that we can use the entire Smith chart for the amplifier design, which is we call unconditionally stable. If the circle is somehow inside the stability circle, let's say it is here, it is but if it is available outside, then the transistor is unconditionally stable. So how to get an unconditionally stable transistor? The minimum condition is nothing but the circle supposed to be outside. The circle is supposed to be outside Smith chart. So how to get the circle outside the Smith chart? We know the location of this center point and the radius. So if we calculate the magnitude of the center and if we subtract from the radius, then the value is supposed to be greater than 1. Then automatically the circle will be outside the Smith chart and we can get the entire region stable region. For the entire Smith chart, a stable region we will get. That is what we want for the unconditionally stable, and the transistor you can utilize for any application easily. So this condition, what we see this condition, if we substitute this two formula here in this two equation, then we will get a new expression. That new expression is nothing but this K. So the K, we are getting everything in terms of S parameter. This del is nothing but determinant of transistor's S parameter, and this value is supposed to be less than 1. The K is supposed to be greater than 1. So this is generally known as K delta test. So the very first thing we have to, once we buy the transistor, after measuring the S parameter, the very first thing we have to do K delta tests. We most probably from the transistor company itself will perform the K delta test, and they will prove that K is greater than 1. So you need not worry, you can buy the transistor like that, they will provide. But as an engineer, we have to confirm that. So first we have to calculate K and del, both we have to check. Then if the condition passed, K greater than 1, del less than 1, then what we will get automatically, this is the Smith chart and the circle will be somewhere outside will be there. Source, load side circles will be from the center, it is very, very far away from it. So we need not to even draw the circle in the Smith chart. But if the test fails, if the value is less than 1, then we may get some circles like this, and we will get some region, unstable region. For example, here there is a simple problem. We are given with the S parameter of a transistor at 2 gigahertz, and the bias condition is also mentioned, and the system impedance is given. Now the S parameter is calculated. Okay, so everything comes with magnitude. The very easy way to understand this, you can see that this is the only parameter will be having greater than 1. By this we can understand which is S21, and the smallest value will be S12. And by the way, we can see that S11 and S22 easily. So most probably when you get the transistor data file or something, this S parameter data we do not know which is which S parameter. We have to identify ourselves. So this is the easiest way to. So now we have to conduct the K delta test first. Here the K delta test is conducted. The very first thing we have to do is we have to find the del value. So what most of the people will do is they will take all the magnitudes and they will apply in this formula. Don't do that. It will give wrong answer. So what we have to do, we have to calculate del. Separately del we have to calculate S11 into S22 minus S12 into S21. Everything is magnitude angle. So they are all complex variables. So we have to utilize the calculator properly in a smart way. Otherwise this itself, many of the people are taking time. They will convert everything to real imaginary part, then they will multiply. Then they will subtract. Finally, you need the value in magnitude angle once again. So if you do a small mistake, everything will be collapsed. So the best thing is you should know how to calculate all these complex variables, all these workout, multiplication as well as subtraction in magnitude angle itself. Then for this, we are separating the magnitude and we are checking this value is less than 1. Yes, this value is less than 1. And we are going to calculate the K value. K value, we are substituting all the important things. Then we will get this value less than 1 it is coming. But what we want greater than 1. So therefore, the test fails. If the test fails, which means the transistor is conditionally stable. They are using other popular name, potentially unstable, but in Poser book it is mentioned conditionally stable, so you have to follow the same name. Now, if the transistor is conditionally stable, we are supposed to draw the circles. So, how to draw the circle? We need to find out this RL, CL, RS, CS value we have to find using this formula. The very important thing you have to remember in this, you can see that this del is coming not magnitude form. This is you have to multiply, and you can see that here also S21, S12 is available, which are already calculated here. So you can see that CL always comes with magnitude angle and radius will come only magnitude. There is no angle for it, only magnitude. And these all values, they don't have units. You can see that there is no unit. So how to draw the circles in the Smith chart? So I'm telling here, so this is half of the Smith chart, and the very first thing we have to do is we have to take the CL value. This is the CL value. This we have to multiply with the radius of the Smith chart. Which is the radius of the Smith chart? The innermost circle. You can see that the innermost circle. So this innermost circle is nothing but, these are nothing but scales. This all are scales. This is the one, the Smith chart. So up to this alone you have to calculate, and this is your mark as radius of the Smith chart. So the best thing, which direction we have to find? Vertical direction or horizontal direction? Which direction we have to take? So you take any one particular direction, that is not a problem, but the advisable one is this vertical direction. You draw a line using the scale or with the compass, you can find the radius. So immediately write the value. Let's say this value is coming 8.5 centimeter. Most probably this value will be correct, but we do not know which Smith chart you will get. So in different companies, they will print it in different sizes. Then you have to multiply with this number. So if it is 8.5 centimeter, then 1.36 into 8.5 centimeter, which will give some value. You can see that the value is greater than 1. Therefore, the center will be just out of the Smith chart. Remember? So here it is clearly drawn. So up to here it is 1. And after that, this remaining part is available here. So this is how we have to mark. So the very first thing we have to draw is we have to draw the angle 47. So this is the 0 degree line. 47 degree line we are going to draw first. This is the first thing you have to draw. A long line you draw. Then multiply this 1 point, whatever the magnitude of the CL, into 8.5 centimeter and cut a point here. So that will give us CL. Keeping this as a reference, you have to draw the circle. So how to draw the circle? We know the RL value, we have to multiply with 8.5 centimeter. Then we will get the circle. So we can easily draw the circle, and the Smith chart may come up to here only. So you can draw within the scope.
So in this, what are the stable regions?
This is actually stable region. Can you see the shadow
the entire
region here?
Smith chart?
Yeah, not the entire Smith chart. This region is
except
unstable.
the shadow part.
So here it is clearly mentioned, which is unstable region. And this is another circle for the input input side. So it is called input stability circle, output stability circle. So we got the circles. For instance, here there is another. So there is a company. It is providing a transistor and its S parameter is given. The very first thing we have to do is we have to calculate. We have to first go for K delta test and we have to plot the stability circle. So that is what the question is all about. So first we have to take del K CLRL. So first we are calculating in magnitude angle form. Then the magnitude alone we are writing here and that we are substituting here. Then we are calculating this value is less than 1. So you have to write the test K delta test fail. The K delta test fails. So we have to draw the circles. So circle we are going to use this 4 formulas to calculate the radius. So this is the angle, radius, angle, radius. So these two are nothing but output stability circle and these two are for input stability circle. So I'm telling orally how to draw it. So first we are having Smith chart. First thing you have to do is you have to find the radius R0. You have to write the R0 value. Then whatever the R0, first we have to draw the line for 132 degree. So we know that this is 90 degree. This is 180 degree. So 132 may come here. So you can draw a big line. And in this line is nothing but 132 degree. Then we have to take the magnitude, multiply with R0 value. That is the radius of the Smith chart. This is 1.59. We know that the point will come just outside the Smith chart will come. Then next thing we have to take the radius and multiply with R0 value and you draw the point like this. Then you mark this region unstable region. Very, very simple. Here also the same 162 degree may come here and another point may come here and you will get another circle like this it may come. So all the circles center and radius are available. Then you can see that this is how the result will come.